So let's start with the lesson for today. Now we're going to discuss the topics that you have been given. First, okay, we're going to discuss what is hydrated salt. Okay. Hydrated salt is salt with water covalently bonded into it. So this is the usually salt has water, but only surrounding them just by being neighbor. They have only weak hydrogen bond into them. So let's say we have M positive and A negative. In normal condition, there will be H2O, 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 which is going to surround them. But the connection between them is just weak hydrogen bonding. You can easily take the water out and the salt is going to be dried as pure salt. So this is Ma aqueous in water. When you dry them, what you have is just M, A, A, M, M, A. You're going to have this pattern like a checkerboard in Ma solid. When you dry them, all the water goes out. What we have is in a solid, pure salt without any water at all. This is what we call anhydrous or not having any water. What happens if we have hydrated salt? Well, we have initially the same condition here, M and A negative. M stands for metal, A stands for anion. Okay. When they are in water, they have initially the same condition, but you cannot see them. They have bonded covalently into them. So when you dry them, you have M and A, but there will be water permanently bonded into them. In this example, I am giving 4 water for every salt one here. This is what we call hydrated. In hydrated, when you dry the salt, the water stays with them, stick with them. Why? Because the bond is covalent bonding, not weak hydrogen bonding. Hydrogen bonding is normally written with a dash, hydrogen bond. Okay. While covalent bond is written with a line. Now, why in hydrated salt we don't see the thing like agar like jelly? It's because the water there acts as a crystal. It no longer acts as a liquid. So if you see hydrated salt, you see them like solid. You don't see them as if like a jelly. In a jelly, you have a lot of water and it behaves like water. But in hydrated salt, it behaves like a solid because the water become part of the crystal structure. Okay, so that back definitions of hydrated salt. How do we write hydrated salt? Hydrated salt is written as the name of the cation, the name of the anion, dot. The dot is written at the same level. Don't put them like a decimal place here. It's written at the same level, and then some number of H2O. X is the number of hydration. Example, you have one of the most common salt to be hydrated is copper sulfate. This is an example of them here. The dot here doesn't mean like multiplication. A dot is manifestation of covalent bond. So in mathematics, if you have A dot B, it means A times B, right? But it's not the case here. So the number 4 only applies to H2O. Okay. Note that we don't have any space at all here. So no space between 4 and H, no space between dot and 4, no space between SO4 and the dot. Write them all like a single word, no space at all. Okay, now this is what is a hydrated salt. Okay, back in the definition. Okay, here, salt with water covalently bonded into it. Sometimes we call them crystalline water. So the water is in the crystal of it, not as a coating outside of it. Okay. Now, is it clear enough now? Okay. Next, let me have them here. Okay. Now I'm going to share my screen, yeah, so you can see some of them here. Can you see my screen now? Hello?
Yeah.
Okay. Now, this is what happens in hydrated salt. As we see them here, in hydrated salt here, we see the sodium here is differently located with the water. This is if we have the common salt, not hydrated. But if we have a hydrated salt, we see them here that the water, H2O, is covalently bonded into them. So they become part of the crystal. Here, we have them, we call them hydrated salt. The water here is inside the crystal, trapped between them. They become part of the family, no longer just freely walking around. There is another one here, if you can see them clearly. Uh, no, not this one. Okay, so that is. So if you can see here, okay, the water is trapped between them. The big blue ball here is the water part. So we see the water become included, okay, become part of the crystal itself. Okay. No longer just the surrounding element. Okay, that is about the hydrated salt. Now let's get into the next question. The next question is, what happens to hydrated salt when they are heated? Okay, when they are heated, then the covalent bond between the salt and the water is going to break down, and the water going to evaporate. Okay, so I'm going to write them down here. Question number 2. Okay. Now, there are two steps who's going to happen here. First, okay, the bond between the salt and water breaks down. Why? Because this is the weakest bond. We have bond between the salt molecule. That is the strongest. We have bond inside the water molecule, hydrogen to oxygen, and that is the second strongest. The weakest is between the salt and the water. So when we hit them, that is the first bond that's broken down. And then after that, the water, okay, they're going to evaporate, right? Okay, leaving what we call anhydrous salt. Okay, that's it. Okay. I repeat. Okay. What happened is the bond is going to break down, the water evaporate, they become a gas. Okay. And then we're going to see the gas become anhydrous. Example, if we have copper sulfate dot 4 H2O. The symbol for heating in chemistry is delta here. Okay. Delta means we are increasing the temperature. We're going to have CuSO4 solid plus 4H2O, but it's become a gas. Of course, it's starting with a solid. So what it means here, now between copper and water, we have an add sign here. The add sign means the molecule is no longer chemically bonded. If you have A plus B, means you just have A mixed with B, but between them, nothing happens. But if you have A, B, means you are linking them in a strong chemical bond, either covalent or ionic bond. So see the difference here. This we have the dot, means we are linked. Now we have a plus sign, means they're simply mixed but not linked. This is linked. This is not linked. And also check the sign for the water. The water of sign here means they become gaseous. They evaporate, become a gas. While previously, the water is a solid part of the crystal. Okay. Up until this, any question? Does it happen? Does it answer the question for you?
No.
No. Okay. So anything else that you'd like me to? Which part of them that you'd like me to repeat? So what happens? There are two things that happens. The first, breaking of the bond. Why that is the bond that's broken? Because this bond is the weakest between the three types of bond. We have bond between copper and sulfate. This is the strongest one. We have bond within water, which is also the second strongest. And the weakest is the bond between the sulfate, uh, any salt, with the water itself, which is the weakest. This is the strongest. This is the second strong, and this is the weak one. Hence, when we hit them, the weakest part breaks first. Okay, clear enough?
Yeah.
Okay. Shall we go to question number 3? Method of preparing soluble salt.
Okay.
Okay. Before we go number 3 and number 4, I think it helps if we go back a bit and talk about solubility of substances. Now we have here three classes of substances. We have acid, we have base, and we have salt. Now we need to know what type of them that is going to be soluble. Acid, okay. All acid is soluble. You never get any acid that is solid or acid is liquid. Why? Because they are soluble. In fact, water itself is regarded as a weak acid. Now, what about base here? Now, here it is, the one that's unusual. Most base, most base is insoluble. In fact, soluble base is so rare, they are given a special name, alkali. Okay. Soluble base is what they call alkali. Now, what are alkalis? Now, in general, alkali is group 1, okay, group 1, okay, group 2, and ammonia. So this is the alkali. Can you hear the drilling here, guys? Hello.
No.
There is some drilling. Drilling. Can you hear the sound in your voice?
No.
I mean, no. Okay, good. Because if it goes, I'm going to ask him to stop drilling. So this is the list of soluble base. Okay. In general, the soluble bases, we call them alkali, is group 1, okay, ammonia, and group 2. Not all group 2 actually. We're going to see them later on. So hence, the alkali is rare. We have them here, ammonium hydroxide, and then we have sodium hydroxide, potassium hydroxide. Okay. Group 2 is soluble, but only in small extent. So usually we don't call them being soluble. We call them sparingly soluble. Such as calcium hydroxide, okay, and magnesium hydroxide. For sure, the one that is going to be soluble is these three. Now, what about salt now? Salt consists of two parts, the M part and the A part, the positive and the negative part. The rule for solubility for salt is for the M part, if we have the ammonium, potassium, potassium and sodium, the group 1, if M here, they are all soluble. I repeat, if on the positive part, the first part, you have ammonium, ammonia, sodium, and potassium, you don't need to check the anion part. It is going to be soluble. They are joker. Okay. Now, anything else, they are likely to be insoluble. Others, insoluble with exception. Oh, by the way, I need to go for a while. Can you hold me for about 2 minutes, please? Sorry. Okay. Okay, I'm back here. For the anion. Okay. Now for the anion, there are strong anion here that whatever on the first part, they're going to be soluble. Okay. They are sulfate. Okay. Now, this sulfate here, they are mostly soluble with exception. What are the exception here? The exception is if we have barium, calcium, and lead. Sulfate comes from sulfuric acid, a very strong acid. Normally, if we have them from strong acid, they're going to be soluble. But if the first part of them is heavy metals, barium, calcium, and the lead, the sulfate is not enough to float them. So they're going to sink, become insoluble. The same with chlorine. The chloride, they are mostly soluble. Except, okay, we have them here, silver and lead. Chloride, bromide, and iodide, those are strong acids. These three of them normally is going to be soluble. If you are given any metal except for silver and lead, they are going to be soluble. Okay, so that's it. That is the rule for the solubility. On the other hand, okay, if we have carbonate here, they are mostly insoluble. Of course, okay, they are going to be defeated by the jokers, these three here, except okay, the ammonium, sodium, and potassium. These three, you can never make them insoluble. They are joker. Okay, so how do we classify, is something going to be soluble or not? First, check the metal part. If they are ammonia, ammonium, sodium, and potassium, they are all soluble. No need to ask about what is the cation. Okay. And the second, check the anion part. If they are sulfate, or we call them halide, the trio of chloride, bromide, and iodide, mostly insoluble, sorry, mostly soluble, okay, but check for special cases. Do we have Ba or Ca or Pb plus sulfate that become insol? Or do we have silver or Pb with either the chloride, bromide, iodide? They become insol. Other than this, then they are insoluble. Done. So two-step process to check, are we going to have a soluble salt or not? About the group 2 that I told you, okay, group 2 here, they are of two classes. Some of them soluble, some of them not. So what are the soluble one? The soluble one is the calcium, strontium, and barium. This is the soluble for group 2. Magnesium is not. Okay, now we know some salt is soluble, some not. Some alkali is soluble, some alkali is not. With that, we can see there are 4 cases possible. Acid plus base become salt. The first possibility is we have something soluble and something soluble makes something soluble. This is case number, let's say case A, case number 1. Something soluble with something soluble, but the result is something insoluble. This is case number 2, the easiest. We have then something soluble with something insoluble, but the result is something soluble. This is case number 3. And the last one, soluble with insoluble become insoluble. This is not discussed in IGCSE. I repeat, because all acid is going to be soluble, but bases and salt, some of them soluble and some of not. So we have 4 possible scenarios. Both of them soluble and the result is also soluble. Now that's so-called case number 1. Then both of them soluble, but the result is insoluble. That's case number 2. This is the easiest. And then we have the soluble acid with insoluble base, but the result is the soluble salt. Now that's case number 3. This is the 3 case we are going to learn in IGCSE. The 4th case is not in the syllabus. That is, we have a soluble acid with insoluble base, and the result is insoluble salt. This is not discussed in IGCSE. Now, we are going to discuss in question number 3 that your teacher says here. This is case 3A. Okay? And this is case 3B. And this is case question number 4 in what is given by your teacher. So your teacher give you 4 questions, right? Question number 1, 2, 3A, 3B, and 4. What your teacher says in question number 3A is case number 3. We have a soluble acid, okay, with an insoluble base, and the result is going to be something soluble. Okay. Okay. Now, let's do the question by case number 3 because your teacher wants it to be the first to be discussed. Case 3. Okay. Soluble acid, all acid soluble, plus insoluble base. Make into soluble salt. Now, what is our problem here? The problem here is this. We have two soluble things. Soluble means they are going to be in liquid. If we want to have a soluble salt, the key idea is how can we make sure there is no acid that is going to interfere with the salt. Why? Because in that case, the product we have will be impure. So the key point here, make sure, okay, acid not mixed with salt in the end. How to do that? Okay, easy. Make sure no acid left. How we can do that? Okay, okay. By make sure, okay, the insoluble base is in excess. This is the key. Is my handwriting clear enough? Sometimes my students complain about my handwriting. If it's not, I'm going to write slower, okay? But then usually better. Can you read my handwriting so far?
Yeah.
Okay. Okay. So here it is. You have liquid acid. You have solid base. So this is liquid. This is liquid because it's soluble, right? Insoluble means you have a solid. And then you have a liquid. The liquid and liquid may mix. If we want to have soluble salt, pure soluble salt, we have to make sure no acid left. So the key idea